So today we're going to introduce the unit circle. Please make sure that you have watched the radians video and understand radians before you watch this video. So the unit circle, remember, is simply a circle with radius 1. It can be 1 inch, 1 centimeter, 1 foot, 1 mile, whatever, as long as our radius is 1. So we're going to start today with a circle with its center. Through that center, we're going to draw an X and Y axis so that the origin, or point 0, 0, is the center of the circle. With a radius of 1, this circle is going to go through the points 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Those points are going to come in handy a little later on. For now, it's just enough to know that they're there. Your first piece of vocabulary today is initial side. Initial side is the radius that starts in the center and goes along the positive side of the x-axis out to 1, 0. This is where everything's going to start. This is where our angles are going to start. This is where our arcs are going to start. Everything in a unit circle begins here. When I create central angles inside my unit circle, I'm going to go in a counterclockwise direction most of the time. Where my angle ends is going to be called the terminal side. So initial means beginning, terminal means ending, so that makes sense, right? Where our angle begins, where our angle ends. And remember, the general term for an angle measure is theta. This is called the standard position in our unit circle. So anytime you have an angle that starts where our initial side is and ends somewhere else in our circle, that's called standard position. Going in a counterclockwise rotation creates a positive angle measure. So like this angle, that's about 120 degrees. If my arrow indicates that I went in a clockwise direction, though, that's going to create a negative angle measure. So this angle, simply because the direction of the arrow is pointing clockwise, this is going to be negative 60 degrees. So here's the big part. We're going to divide the unit circle into different angles, and we're going to measure those angles today in radians. So really remember, we're measuring the arc length and comparing it to the radius. Since our radius is 1, it's fairly simple. So where our initial side is, or where we start, that's going to be 0 radians because I have no length for an arc here, right? That's 0 pi. I can also say that that same point is 2 pi radians because by the time I get all the way back around to the beginning of my circle, that's 2 pi radians. My semicircle, right, half of a circle, my 180 degree angle, takes me over to pi radians. That is half of my circle, and half of 2 pi is 1 pi. So we're going to take this half of a circle, or this pi radians, and we're going to split that up into different units. So first of all, I put in this blue line in the center, and do you see how that splits it in half? So I'm going to say that I'm splitting this half of my circle into half pieces. When I get to the top of this circle, that is half the distance to pi. So this is half pi radians, or I can say pi over 2 radians. I can take half of pi. I can take 2 halves of pi. 2 halves is just 1, so that's where pi is. I can also keep going. By the time I get around to this area of my circle, that's 3 of those half pi pieces. So this is 3 halves pi, or 3 pi over 2. And I can keep going and make that 4 halves, but 4 halves is the same as 2 pi. Now I'm going to take that same half of my circle, that same pi radians, and I'm going to divide it into 4 equal pieces. So these are fourths. Here's 1/4 of the weight of pi. 2/4 of the weight of pi is the same as 1/2 pi. 3/4 of the weight of pi, and 4/4 of the weight of pi. I can continue splitting this circle into those little 4th pi pieces. So I have 1/4, 2/4, 3/4, 4/4. Now I can have 5/4, 6/4, and 7/4, even all the way over to 8/4 if I needed to. Reduce fractions, of course, so like the 6/4 becomes a 3 pi over 2, 8/4 becomes 2, and 4/4 becomes 1 pi. So make sure fractions are reduced, but other than that, that's kind of how it works. Let's go back to our original pi radians, and this time let's split it into thirds. So here is 1/3 of the weight of pi, 2/3 of the weight of pi, and 3/3 of the weight of pi. So I have pi thirds, 2 pi thirds, and 3 pi thirds, which is the same as 1 pi. I can do that to the other side of the circle too. So now I have 4/3 pi, 5/3 pi, and 6/3 pi, which is the same as 2 pi. Let's try that again, only this time, let's split it into sixths. Sorry, that's a really hard word for me to say. So now I have 1/6 of the weight of pi, 2/6 of the weight of pi, 3/6, 4/6, 5/6 pi, and 6/6 pi, which is the 1 pi. I want to reduce fractions, right? So 6/6 is going to become 1 pi, and so on and so forth. I'm going to do that to the other side of the circle as well, and I'm going to continue where I left off. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and you get the picture. I of course want to reduce any and all fractions, and you can kind of see pieces and glimpses of measures that we've had before. 2 pi over 6, 2 over 6 reduces to 1/3, so 2 pi over 6 is the same as pi over 3, which means I'm 1/3 of the weight of pi. 3 pi over 6, 3 over 6 reduces to 1/2, so 3 pi over 6 is the same as pi halves, and so on and so forth. Make sure to reduce fractions and you'll be okay. So here I have some of the pieces I had before. This is what I have when I divided it into sixths. I'm going to add in our fourths. I already have all the halves in there. And I can even go so far as to add in eighths, right? This is 1/8 of the weight of pi, 2/8, 3/8, 4/8, and I can keep going around the circle. So if you don't see all of the little pieces, looking at the unit circle as a whole can be overwhelming because you can see all of those little measurements in there. But if you look at them one denominator at a time, it makes a lot more sense. Remember that Your denominator is going to tell you what kind of measurement you're looking for on your way to pi, and again on your way to 2 pi. This is kind of what you're going to have to do for your assignment this next time, is fill in some of these radian measures. I'm also going to have you convert the radians to degrees on your assignment, so make sure that you know that conversion fraction. Have a great day. I'll see you soon, and bring any questions that you have to class.